For section 4.2, we will be talking about angle relationships and triangles. And we're going to start off here with the triangle sum theorem. That is something you already know, that if you add the measure of the three angles of the triangle together, you will get 180 degrees, no matter what kind of triangle it is. And then a new piece of information here is an auxiliary line. And this is a line that is added to a figure to aid in a proof. So as you can see here, this dotted line L is an auxiliary line that we added to the triangle so that we could walk through this proof. So you drew the line L parallel to AC through the point B. So that's the parallel postulate. We made a set of parallel lines there. AC and then line L are parallel. And then I noticed that my congruent symbols did not transfer over into Cami. So these are supposed to be congruent. Angle 1 is congruent to angle 4. And angle 3 is congruent to angle 5. So 1 and 4 are the same. And 3 and 5 are the same. And that is alternate interior angles because they are on the inside. Remember, your parallel lines are here, so they're inside of the parallel lines, and they're on opposite sides of the line, so alternate interior. Then that takes us down, when we know that the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 3 equals the measure of angle 5. If they're congruent, that means they're equal, and that's the definition of congruent angles. And then we also know that if we take those angles, 2, 4, and 5, if you look at our picture, 2, 4, and 5, they form that line L. They would equal 180 degrees, and that's the angle addition postulate and the definition of straight angle, of a straight angle, because it makes a straight line, so it's 180 degrees. And then all three of those takes us down to the fact that we could add the angles 1, 2, and 3 together to get 180 degrees, and that is by substitution. So that is by taking the one that's not repetitive here. So angle 4 is here and here. Angle 5 is here and here. So we're taking the ones that aren't repetitive and adding them together, and we get the 180 degrees. Example 1 here says the map of France commonly used in the 1600s was significantly revised as a result of the triangulation land survey. The diagram shows part of the survey map. Use the diagram to find the indicated angle measures. So for part A, we have to find the measure of NKM. So if we look here, NKM is this angle, this angle right here. So we're just focusing on this little triangle. And if we already know two of those angle measures, one's 88 and the other one's 48, then we can add those together. And we get 136. And we know that the third angle that we add on will give us 180. So we have to figure out what the difference here, what is missing. So it looks like 44 degrees. So the measure of angle NKM is 44 degrees. Then it asks us to find the measure of angle JLK. So JLK is right here. And we have to figure out what this angle measure is. And as you can see here is a straight line. And we just figured out that this angle is 44 degrees. We know this angle, and we're missing this angle. So those three angles together form a straight line, and a straight line is also 180 degrees. So we know the 104, and we know the other one's 44. So if we add those together, we get 148. And we know that the missing angle is going to give us 180. So I'm going to subtract, and we get 32 degrees. So this angle here is 32 degrees. Okay, now another vocab word here is corollary. and that is a theorem whose proof follows directly from another theorem. So we have two of them here. The first one says that the acute angles of a right triangle are complementary. So if we add the two angles that aren't the 90 degrees, so if we add this one and this one together, D and E, that they're going to both equal 90 degrees. They're going to equal 90 degrees together. Well, that makes sense because if this one's 90, these other two have to equal 90 to get to 180. And then the second one says the measure of each angle of an equal angular triangle is 60 degrees. And that would make sense too if all the angles are equal to 180, and if they're saying the three angles are all the same, then they have to be all 60 degrees, because 60 plus 60 plus 60 would give us 180. Now in example 2 here, we're going to say that one of the acute angles in a right triangle measures 22.9 degrees. What is the measure of the other acute angle? Well, we just got done talking about that they have to equal 90 degrees. The two acute angles have to equal 90. So then we just have to figure out what's missing to make 90 degrees here. So we are going to do 90 minus 22.9. So I'm going to have to do some borrowing. And I get 67.1 degrees. So the other angle is 67.1. Now we're going to have 5 vocab words here. We have talked about 4 of these before, so you should be well aware what the 4 are. Interior is the points inside a figure. The interior is on the inside. Exterior is a set of points on the outside of the figure. Exterior means outside. Interior angle are the angles formed by the two sides of the triangle, and those are the insides. Exterior angle is formed by one side of the triangle and an extension. So if you look at the picture here, we have this line coming out of that triangle. So angle 4 is an exterior angle because it's outside of the triangle. And then the newest one here, remote interior angle. That's an interior angle that is not adjacent to the exterior angle. So not adjacent to angle 4. And remember, adjacent means right next to or sharing a part of a line, next door, whatever you want to say. So 3 is definitely adjacent to 4. It's touching it. So angles 1 and 2 are remote interior angles of angle 4. And then exterior angle theorem here says that the measure of angle 4, which is our exterior angle, is the same as adding those remote interior angles together, that 1 and 2 there, that the angle measure is going to be the exact same. So here we have to find the measure of angle J. Well, we know 126 on the outside there, so we know that exterior angle is 126, and we also know that that angle is the same as adding the other two interior angles together. So 6x minus 1 plus 5x plus 17. So we know that adding those two together is going to give us that 126. So now I'm going to combine like terms over here. I have 6x and 5x, which would make 11x, and I have negative 1 and positive 17, which would make positive 16. And now I have to figure out what x is. So I'm going to minus 16 from both sides. I get 110. And then I have to divide both sides by 11. So x equals 10. Now they asked us for the angle of measure, the measure of angle J. So that is 5x plus 17. So now I know that x is 10. I can plug that in. So I get 50 plus 17 is 67 degrees. Moving on here, we have one more theorem to look at, and it's called the third angles theorem. So if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent as well. So in the picture, they're showing that L and R are congruent and that M and S are congruent. So if we know those two are congruent, then we are for sure that N and T have to be congruent because they have to equal 180 to be a triangle. So by knowing that two are congruent, we can prove that the third is congruent. All right, here, so we have to find the measure of angle C and the measure of angle F. So if we look, we can see that E is a right angle and B is a right angle. So those are the same. And also, the other one that we know is the same is angle D here and angle A. So that leaves C and F left over so that we know that those two are equal to each other. So I know that y squared is the same thing as 3y squared minus 72 because if two angles are congruent, then the third set of angles have to be congruent or have to be equal. So now what I'm going to do is I'm going to solve for y here. So I'm going to minus y squared because remember we always work with the lowest amount. So there's 1y squared. So that would leave 0 here. And this would leave 2y squareds here. Then I'm going to add 72 to both sides. And then I'm going to divide by 2. So I get 36 equals y squared. And y squared was one of those angle measures. The measure of angle C was y squared. So we just solved that right there. We know that y squared is 36. So the measure of angle C is 36 degrees. And we've talked about this, that these two angles are congruent. So the measure of angle F would also be 36 degrees. And if you wanted to prove that, you could plug in 36 for the y squared here. So we'd have 3 times 36 minus 72. 3 times 36 is 108, and then we have to subtract 72. So we get 36. So this equals 36 as well. So we can prove that there.